Now we're going to be going into a few special data types. So first let me just paste this over here and create and assign character storing variable values. So this is where I'm going to pause on the code and let's move on. The character storage variable is the char. Now the char stores single characters under single quotations. So char sample char is equal to A. As you can see here, again, the value is not used, so it's warning me, but I can safely say that the variable sample char of type char has been created and stores the value for the character A. And now we can just simply end the assignment because that's all there is to character storing variables, because these are the primitive variable types, and of the 8 primitive variable types, the char is the only one that stores characters. There is another variable type that we will talk about in the near future that, you saw over here. You saw in this program. The robot is cool. You must be thinking, how do you think we would store this stuff in double quotations in a variable? Well, that's a good question, and we'll be exploring that in the next video. But for now, we're sticking to the 8 primitive variable types. So the 7th one is the one here, char. It stores characters, character, char, easier to remember that way. Now, we're going to print, my bad, let's close that, that would have gotten ugly, the char variable categories values. Value, really. Now, system.out.println sample char, and you can now say that this line will print the char sample, the char variables. See how this is starting to make sense? And the printing process. And we'll just do it again. Don't know why I have these slashes, but they are removed. And let's begin our last category. So what this category is create and assign true and false variable values is how I'm going to classify it for now. I'll share the name with you shortly, right after this, and the assignment. And in between these, we perform our assignment. It's like a little assignment sandwich. So we have it's called the type Boolean. Funny name, but you don't want to mess with this variable, Change the value once from true to false and you're pretty much screwed for the entire program. You will see demonstrations of this as the season, or not the season, the series progresses. So here we're going to define a boolean sample boolean equals true. And the variable sample boolean of type boolean has been created and stores the value true. And then we can go over and create something else. Boolean sample boolean 2 is equal to 1. Sorry, my bad, false. The variable sample boolean 2 of type boolean has been created and stores the value false. Now in most programming languages you can also store it as 0 and 1. Sorry, but this was a bit misleading, but in most languages you can store it as 0 and 1 and make comparisons, which we will be making, but not in this tutorial. So we have two variables that are both booleans, so let's print them. Print the boolean variable values. My bad. And printing okay, fun part. And as you can see, the light bulb went away. And let's do it one more time. And semicolon. Print the boolean variables value. And the same thing. And let's run it. Nice. Forgot one thing, and let's go back and do that. And make it a bit prettier. And this is a lot better. So here we have, subheadings, and that's cool. So now you might be thinking, are we done with variables? What if I wanted to change the value of a variable? What if I wanted to do this? What if I wanted to do that? And now we're going to be going into that. So before we do that, I'd like to take a recap and go over everything that we've done so far. So if we take it from the top, an int is an integer storing variable. It's generally considered the default. It's the Goldilocks of all of the integers, and this is the limit that it can, this is the least it could be, this is the most it could be. Not really important with the small values that we'll be using in robotics, but you should definitely keep this in mind. The long takes up more data, but you can also reach higher and lower values because of its greater data width. And so therefore, the long is longer than the int, the short is shorter than the int, and it takes up less data, and its limit is definitely less. Its range is smaller. And the byte, you can think of it as a byte-sized variable, which technically that is what you say, it's a byte-sized variable. But negative 128 to 127, that's the numerical range, and that is the smallest variable type out of the 8 primitive variable types we are going over today. For decimal storers, the double and the float. The double is the default decimal storing variable. These are the values that it can approach. It can go down to negative value for this, positive, negative, and positive. Same thing here, negative, positive, but the float variable takes up less data than double, so you can really go for small numbers with the float. It's also used for that. So for example, we assigned the value 3.4 to the float, and that was definitely very helpful because that was a smaller number you could write as a fraction. As it doesn't have to be something you write as a fraction, it's just a guideline that programmers tend to use. And now if we go to character storage, the char, or the character variable type, stores single characters. As you can see here, it stores the value of A, and use single quotation marks as signaled here. Remember that in the Hello World program we had this series of characters, and this is not a char. First of all, they're surrounded by double quotations, and second of all, this is a lot longer. And for more information on that type, because it's not a primitive type, we will not go over it in this video, but we will go over it in the next one. True or false. So this variable type is known as the Boolean. Again, you would mark it as true or false. And those are really the two values, and it's definitely a very simple value. And that's the job. It just stores two values. Actually, I think amongst Boolean and byte are two of the smallest variable types here. So if we go through the process of what we've done in the code so far, I'm going to be very brief because I've already explained the meaning of the variable types. So here we've talked about how to declare a variable. You declare its type, the name of the variable, and then its value. That's when you're initiating it for the first time. When you're not initiating it, you just don't put an equal sign, but then you do create it for the first time. So, let's just do one for fun. Int not initiated equals, nope, just not initiated. As you can see here, it says it's not used, it's not initiated, and that's okay. So now we're going to go down. So we created and assigned integer variables. So the integer sample int is equal to 3. That's the int variable type. For short and byte, it's the same thing with this, just with the limits. So you could always make this bigger, but you can't make this as big. We all know. So if you assign this to be 1,000, there you go. The error, it has exceeded the range. You can assign it to 100 because of the limit. The limit for byte again is this, so 100 falls in between those. We're going to assign it to 1 for now, just keep it simple. Now for long, the long variable, you can make it as big as not as big as you want, but for integers, you want a big number, go for the long variable type. It does take more data, but totally worth it if you're going for really big numbers. And you would end with a capital L. That is not optional. You have to use the capital L because that signifies that it's a long variable and that it's bigger. Big people want respect, so the big variable type wants respect for the integers. And then of course system.out.println, we're just printing. On println, you're just hitting return, so basically you hit return, next line, hit return, next line. Therefore, you hit return, next line, hit return, next line. And similarly, you've printed out all these variables right here, and you can see that you don't have to say int. In fact, that would be wrong. You can't initiate a variable in here. But as you can see, you can use a predefined value instead of saying 3. You just say sample int because it doesn't matter which variable, or sorry, what the value is here because it's changed up here. Now again, we just created this, so it's an empty line, but it does hit return because of the println. So we keep going. We've made that right there. For double, we have created a double variable with this value. That's an estimation for pi. For float, we created something simpler. We can write as a fraction. That's 3 2/5, converts to 3.4. And the capital F signifies that it's a float. This is not optional, so let's recap. The float and the long variable types are non-negotiable. They must have their special letters. It's literally the capital of the first letter of the type, so it's not that hard. Let's see. Keep going down. We want to print this out, so we printed it out in a similar fashion with one for each line and then an empty return. Now we go into character storing variables that are primitive. So that's the char, or the character I like to call it. Sample char is the variable name. And under single quotations, we have assigned the value of the capital letter A to the sample char. So that's good. And we have printed it out right over here. Empty return. And then finally, true or false, that's the Boolean values. The first one has been assigned true, second one false, and we can print it right here. We can also just print it right there, and it would do the same thing. The reason that it did the same thing was because this is a line that is executed that actually runs. These lines just assign a variable, so nothing actually happens on the screen. So technically, when I printed the line up here, I told the computer to print the line, hit return, and wait for the return. So it hit the return, and it waited for it. So if I removed these two lines, commented them out, up to this point, I've told it to hit return because of the line. I've assigned two variables in the process. Then I say, okay, you already have a return, so just save that. And I want to run it. There we go. Because you hit return and you already saved it and it was waiting for the next command, it ran. And over here, runs the next command. So this making a little sense? I really hope so. So now we've gone over basically how to assign variables and how to print them. Now we're going to go into a little bit more interesting stuff, which is how to change variable values. So let's just say change a couple of variable values. Now before we begin, what I want to say is, if you change a variable value down here, what you print up there doesn't matter because the computer reads the code in steps. So if you think of it as a timeline, when I say to print out sample int, it's going to print out the last thing that sample int was. That's 3. Now if I assigned it to 2, it would print out 2. But if I assign sample int again to 2 over here, this would not print 2. It would still print 3 because when you execute line number 23, line number 70 hasn't happened yet because computers go line by line, as we've said, step by step by step. You have to define every single step. So now we're just going to change a couple values. The sample int is equal to 600 now. And, change variable name, value, not bad. Let's see, sample char is equal to G, change variables value, and, let's just do a, I don't know, float equals to, why do I have quotations? 600 f.0. Because it's a decimal, for these, you have to put a decimal no matter what. So if I did this, it would still work, but it would return it as another number, which you will see. So change variable value. So now we're just going to end change and just copy this, have an empty return, and just keep moving on with life. So print changes system.out.println changed values. And what's cool about, I'm going to teach you a cool trick, is you can combine these with values, and this is really cool. It's just like addition. You'll see it's really easy. So the int variable plus, because I've included a space here, so it'll include a space, plus sample int. I think you know what it's going to do. And that's very neat what it's going to do. And you'll see. Char variable, sample char, system.out.println. Oh, my bad. And my bad again. Float variable, sample float. So I'm gonna end the printing. So recap, we've learned how to create variables, assign them to values, print them out. Now we can see that you can change the variable at any time, but the changes only apply from the moment you change them. So any changes, anything that happened in the past is using values before these. Alright, so sample int is 600, but before line 70, sample int was 3, because sample int was not changed until line 70. Because the computer goes in steps. So until step 70, it only knew that the sample int variable is equal to 3. Then in step 70, we told it that it's equal to 600. Now, we're going to run and let's see what happens. And there you go. You have combined this quotation mystery object with actual variable values. How neat is that? That is really neat, isn't it? So, you know, you can do whatever you want. You can say oranges, I don't know, 600 oranges, I don't know. You can do whatever you want. It's really, really neat. So you should definitely try that out. That's definitely something you will be using when you program, you know, just the space, and that's pretty cool. And, you know, as you can see, because the float variable, I just like to point out, is a decimal, no matter what, we assigned it to 600, but it returns 600.0. And that's something the double variable will do as well. So if this were a double, so sample double, which was our variable, is equal to 600, it would do the same thing. So what I did was, again, I'm going to go back. I had a sample float equal to 600. I removed the f. I call that sample double. So the sample double variable, now I modified the sample double variable just to experiment. Then I took sample double here and I matched the two. So now I'm using the new value for that, just to see if it'll return the same value because they're both decimals. And probably want to change that to double. hit run, and what do you know? It's the same. So that's that. You now know at the end of this program, you now know how to. That's the cool thing about multilinear comments. It does this cool star thing. Oh, I spent so long playing with those. Anyways, you know how to assign variables, use each of the 8 primitive data types for the Java programming language, and you know how to print the variable values and change the variable values, not values, at any given time. And now just to try one last thing, assign a value to a lonely variable. Remember, we had that lonely variable up there, not initiated? Well, non-initiated will become initiated. Non-initiated equals to 14. Oops, think we called it something else. Not. Dang it. My bad. Print the corresponding value non-initiated, and we can be cool with it. This variable now has a value non-initiated not. I did it again. Ugh. Anyways, and printing. There we go. Assign. Now you also know how to declare and assign at 2 different points if you wish. And if I run it, this variable now has a value, 14. Neat, huh? Didn't include the return, but to be honest, it doesn't really matter. I trust you guys, and I think you're good. Go back to this video if you have any questions, because this was really, you have to get these basics down. And so really, we are all proud of your accomplishments with this program. You have written, I wrote, well, I cheated right there. And minus the, well, you need the spaces. So, you wrote about 100 lines of code today. So good job, and really keep it up. You now know how to use variables, and we're going to go into a very interesting variable type in the next video. So if you have any questions, please comment below. Please subscribe to our channel. This was First Aid for Coding, brought to you by Cupertino High School Robotics, and have a nice day.